This lecture is an introduction to R, including some basics of R programming language, such as defining variables and making loop statements and importing and exporting data and even installing this software. But the thing is that R is also programming language, and this lecture is kind of a basic thing. If you're not familiar with programming language, programming, I mean, then you may have to, in fact, you should practice many times. It requires many practices to be familiar with the programming. So I recommend you to practice all the R programming code by yourself after watching this video clip. And I know that there are many good materials out there, such as in YouTube. If you search for some video clips using the keyword R, then I think you can find many good materials, many good video clips. So after watching this video, if you think that this is not good enough to know about our software, then please go move on to another material that you find from the internet. So I also recommend to watch other materials if needed. And the other thing that I wanted to mention is the homeworks given to you in this semester requires to use our software. So I know that there are some chances to practice our software, but anyway, I just want to mention that you have to use our software to do your homework and to do your final project. Okay, so let's move on to the next slide.
So what is R? R is an environment for statistical computing and graphics, and it has a suite of operators for calculations on arrays, particular matrices, or vectors, or numbers. And it's a kind of programming language, but most people use it interactively, and it's a kind of interpretable language, and you don't have to compile your code to execute your programs. So you should have R installed on your computer to execute your code, your R code. So it's a very well developed and simple and effective programming language that includes conditionals, just like a general purpose programming language, such as Java, C++, and so on. So it has conditionals, loop statement. You can use loop statements such as a for clause, while clause, while statement, and you can define your own functions, and it also provides several useful built-in functions as a default. And it has input and output facilities. You can write the data in the R into the external data files such as Excel, CSV format, and TXT format. And you can also read data from external files that has the same format such as CSV file. And the most functionality is provided through built-in and user-created functions. I just talked about the functions, and the details about the functions will be explained later over this class, later over this slide. And basic functions are available by default, and other functions are contained in packages. So there's a set of built-in functions, and the other functions you can obtain the other functions by downloading and installing the packages from the R website. And those packages can be attached to a current session as needed if you need some specific packages. So for example, if you want to do a logistic regression, or if you want to do a testing hypothesis, something like that, then you can download packages that perform such things from the R website. And what is really good about R is that it's free and also software, so you don't have to pay. You don't have to pay anything. It's just free. Go to our website and download it. And versions of R exist of Windows, Mac, Linux, and various other Unix flavors. So you can choose your own R, which is that depends on your operating systems. So where to get R? This slide shows this address, cran.r-project.org. If you go this site, let me go to this stuff. Then you can see the title of this site is the Comprehensive R Archive Network, and here are just 3 links. So because this system is Windows, I will just click this one, and here is several options, and you just click base, and the current version of R is R 3.1.1, and it's about 45 megabytes. So it doesn't take long to download the whole R installer. So to save your time, I already downloaded that installer on the desktop of this computer. So by clicking that installer, it's pretty much same as installing the other softwares, and execute. And here you can choose the language, the version of language of R. So here we have option of Korean, but because this class is supposed to be taught in English, I will choose this one, English, and OK. Then you will see this window to install the R software. Let's just click next, and this window asks you where to install. Next. And if you have a 64-bit computer, then you can check this one. Or maybe this installer automatically recognize the spec of the specification of your computer, and I will just click next. And startup options. Do you want to customize the startup options? Please specify yes or no. Well, I will just accept defaults. Just click next. And don't create, okay, I will just click next. Well, click next. Then is installing the R software to the desktop. It takes a little. Then after extracting files, well, you click this one, finish. Then after installing R, you will see this icon, and by double clicking this one, you can run. You will see this R software opened. And here's R console, and see here is what is this? The prompt symbol, and the cursor is blinking, and you can type here your command, R command here. So for example 1+1, and push the enter, it returns 2. something like this, and you can write your comment on the new script. You can write here as well, 1+1, and you can copy this one by Control C, and click this one, Control V, then it shows to the same result. Anyways, this is R. It's pretty easy to run to see this starting screen. Okay, let's go back to the lecture slide. So after installing R, you will see R console and R editor. So output appears here in R console, and also directly you can type your command here, just like what I showed you just before. And here, using the R editor, you can write small bits of code or long lengths of code here, and you can run it. And if you want to modify your code, and you can, if you want to adjust your syntax here, well, depending on what you got on the console, then you can modify that and run again. So write your code here and see your result here. So you can communicate with R interactively. So at the end, all you need to do is save your script file, then you can easily rerun what you did just before. Isn't it easy? Okay. So our sessions are interactive, and it defaults to an interactive mode, and the prompt, this symbol, is presented to users, which means that it's ready to receive your command, your statement, R statement. And each input expression, that R code, is evaluated and a result is returned in the R console. But as you saw just before, the interface of R is not that good. It has just small sub windows in there. So I recommend you to install an additional software, which is R Studio. So R Studio is also free. So click this one. You will see this website, and click download R Studio. And there's two types of R Studio, desktop and server. R Studio desktop, and well, something is not free, but the R Studio desktop is still free. Isn't it real good? So you don't have to pay anything. You don't have to pay any coin, any penny. So, well, you can choose something. You can choose the one that is suitable for your computer specifications. And by clicking this one, you can also download the installer of exe file to install R Studio. But this one I also downloaded already on the desktop of this computer. Actually, I'm in the classroom to record this class. And so here is our Studio installer. And double click this one. Okay. Next. This is written in Korean. Just click next, next, and next. It doesn't take long to finish installing. finish. Where's the RStudio? Programs. No. Oops. Just a second, I'll be back. Yes, I found it. So programs. Here is a RStudio, and I will drag this out to the desktop. Then you double click this one. Then it brings up to you, the RStudio to you, and it automatically records these R sessions. By double clicking this one, you will see this window, and R session is already started by starting this RStudio. So this window is pretty much better than that R thing. Here's R console and some history. This is the history of a command, R command, and files, plots, several. Here you can see several tabs. Files, plots. If you draw some pictures or graphs using R command, then you will see that result from here. Packages, help tab, viewer. I don't know about this, but this one is very useful. Help tab. And here's some icon. This is to open a new R script. So this one is editor of R. So just like what I showed you before, 1+1, and select this R statement and run. But you can do the current line or selection by click this one and by click Control plus Enter. The same thing happens here. 1+1 equals to 2. But you can also still directly write your command on the R console, 1+1 here, like that. So it's much better for us to see these whole things, one view of the screen. So that is RStudio. Here's R editor and R console and several useful tabs that I will explain you in more detail later. So R is just like MATLAB. If you have an experience of using MATLAB, then you can imagine it. It's a calculator, so you can do anything, any calculations using R. So for example, 1+1 returns 2, 1+1 times 7 is, because it first calculates 1 times 7 is 8. 7, I'm sorry, is 7. 1 plus 8, 1 plus 7 is 8. But you can use this parenthesis. It returns 14, and it has many built-in functions that calculates more advanced calculations, such as log and square root. And you can define variables using R, using this expression. So this R expression, x, left arrow, and 1, means that we want to store this value of 1 into the R object, which is named x. This means that y has 2, and this means z has 3. But most of our programmers, as I know, to define a variable they use this convention, this left arrow. So let us go back to R Studio. So I will select all and delete. A left arrow 10 and control enter, then A has now the value of 10 here. And this environment shows that what kind of R object you have on the current R session and what kind of values in there. And I will assign 5 to B and control enter. Then B has 5. And now I will do some simple calculations like A plus B. Then it returns 15. You can use R as a calculator, just like this, and you can define variables using this left arrow expression, left arrow convention. And what you have to keep in mind is that R is a case-sensitive language. So here, U in capital letters and U and this U, all these are different. So they are recognize all these things as a different R objects. So you should know that the R is a case-sensitive language. And you can get some helps. So anytime if you see some word in the parentheses, something like just something like here, for example, mean. Actually, this is for calculating the average of some values, 1, 2, 3. I will just show you that. So this mean is a function. I'm sorry. But so as I just told you before, anytime if you see this thing with a parenthesis, then this one is a function. But sometimes you want to know what those functions are, then you can use this help function. Help, and you can type here the name of a function that you want to know about. Then here you can see the explanations about the functions on the help tab here. It provides the description of the function and how to use it and what are the input arguments and what this function returns and some related functions with that function and some examples of our code. You can see. You can use this help tab. I'm sure you will use this help function in the future very frequently. So you can type either help or this question mark. This example shows the this example uses this matrix function, and this on the help tab you will see the details about matrix function. So R provides help facility, and it is useful for you to know about this help function. And R actually predefines its own data types that are vectors and matrices, arrays, and data frames, and lists. That I think that's in R and vectors, and I think those are enough for you to handle the different types of data in R. And the vectors, that the vector has 3 types of vectors: numeric vector, character vector, logical vector. Yeah, that's it. So to create a numeric vector, you can use this C function. This C is short for concatenate. Using this concatenate function, you can create a numeric vector. Just like if you type here C 2, 3, 10, 5, then it's a numeric vector and its length is 4. And you can store this numeric vector using this left arrow convention. C 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, something like this. Then a vector with a length of 6 is stored in X. So by typing X, you can return this vector that you previously stored, you previously defined. And here is a, what is this? A colon symbol. Using this one, actually this is for sequence function. So here, let us get some help using type this one. Then this SEQ function generates regular sequences, and it generates a numeric vector. So for example, SEQ 1, 2, from 1 to 10. So it has three arguments. 1, 10, let us type 2. Then it generates 1, 3, 5, 7, 9. So this command here means that you create. So using this one, you can generate a sequence of numbers. So from the previous command, you can increase 1, then it generates the vector with length of 10, from 1 to 10. So the first input argument indicates the starting number, and the second one is the end number, and the third input argument indicates the increment of that sequence of numbers. That is a sequence function, and if you want to use the increment 1, then you can I'll say omit this part, and so this one generates the same result. And you can do the same thing with this expression 1, the colon, and 10. It means that from 1 to 10 by increasing 1. So this is the type of numeric vector, and so here the W has the length of 50, a numeric vector with the length of 50, from 1 to 50, 1, 2, 3, 4, and so on, and up to 50. And you can create a character vector using the same concatenate function here, C. So this one means that we would have a character vector of length 3. I'm sorry, length of 3. And the logical vector means that the elements in the back in a logical vector would have either true or false here, true and false. But the true and false should be typed in capital letter. So it's the same that we're using this C function, concatenate function. So I will just do this example. Select those things and paste it. So running the first line, results in here results in a logical vector which elements are true, 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 false, true, false. And this one generates a numeric vector which is A, and the third line also generates a numeric vector which element is 1, 1, 3, 3, 5. And here actually R, you can do what is that, comparisons. You can, R has a comparison operators, something like equals to, less than or equal to, less than or greater than, something like that. So here A is a numeric vector, B is a numeric vector as well, and A equals to B. If you learn this part, then it returns a logical vector. And this comparison operator compares these two vectors element-wise. So the 1 equals to 1, true. 2 equals 1, false. 3 equals to 3, true. 4 equals 3, false. 5 equals to 5, true. So it generates this kind of logical vectors. And you can refer to the elements of a vector using subscripts, something like this. And here, this, well, I will define an R object C by comparing A and B. Then C is a logical vector. And if you subset C, so if you refers to some specific elements from C, then you can, well, I will change the name of C because it's confused by the concatenate function. So F. Now, F is a logical vector, and then if you want to refer to some specific elements, then you can use, you have to use this square bracket 2. Then it returns the second elements of F. The same for the numeric and character vectors. A is a numeric vector, A is square bracket, and 4 returns the fourth element, which is 4. And the multiple elements also can be returned using this one, A, square bracket, C, 2, 3, 2, 5. It means that, let us see the result. It returns the second elements and fifth elements. So in this square bracket, this numeric vector, you can use a numeric vector in this square bracket to return the multiple elements from vectors. It's same for the character vectors. Okay. And matrices. So this matrix is the matrix is the matrix that you can imagine. So the all columns in a matrix must have the same mode. Mode means numeric or character or logical or. So the one column has the same mode. And the general format, the syntax of using matrix is, here my matrix is a variable name, and using this matrix, the first argument is a vector. So this matrix function creates a matrix from a vector. It could be a logical vector, or it could be character vector, it could be numeric vector. And the second argument is the number of rows, n row, n number of columns. And by row means that if you want to fill a matrix by row, then it should be true. But because the default is it fills a matrix from the values of a vector by column. So by call is the default option. So by row true indicates that the matrix should be filled by rows, and the false indicates that the matrix should be filled by columns, which is default. And this 1, 2, 3, 4, fifth elements, you can give the column names and row names to created matrix using dim names. I will show you the examples in the next slide. So here, let us see. This is the first command. Y is a variable. So we want to store a matrix into R object, which is named Y. And here the first argument is 1. Actually, this is a sequence function. So the type of 1 colon 20 is a numeric vector, right? And n row is 5, n core is 4. Then the result is so using this one, because the default is filled is to be filled by column. It filled this one first, and then this one, this one, this one, this one. So 1 to 5, 6 to 10, 11 to 15, and 16 to 20. So it generates a matrix which dimension is 5 by 4. It's pretty easy. And the second example is, so actually you can create a matrix by creating a vector. 2 to 20, I don't know, 6, 1 to 10 by 2, and the number of rows is, this is odd number, to 11, then 1, 3, 5, 7, 9, 11. And the number of rows is 2 and 3. It generates a 2 by 3 matrix. So you can type here n core. It generates the same, not the same thing. Sorry, I mistyped. N row. It generates the same thing. So it's good to try several different things. And so you will see the results by doing this example here. And you can subset a matrix using this square bracket as well. So here in the current R session, is there a matrix? No. So, okay, I will store this to A. Then A is a 2 by 3 matrix, and A square bracket and 2, comma 3. It means that it returns the second row, the elements at the second row and third column, which is 11. And 1, comma 3 is 9. And by deleting this one, the first argument in the square bracket, it means that it returns the all rows of third column, which is 9, 11. And I forgot to say to you that actually there is no distinction between a row vector and column vectors. Row vectors and column, there is no distinction between those. So actually the default type of vector in R is a row vector. So even though it's a column vector, it generates a row vector because there is no distinction. You understand that? And this means that all rows at the second column, which is 5 and 7. So the type of this result is numeric vector, right? And you can also use So I will make a bigger size of matrix A. Matrix 1 to 25. The number of row is 5. The number of column is 5. Then it generates a matrix. And you want to subset some specific part. Then A 2, 3 returns the value at the second row and third column. So the first argument indicates the row and the second one is column. And A square bracket and C second row and first row and first column and third column. Let us see the results. So it brings out second row and third row and the first column 2, 3 here and 12 and 13. So the result, the type of this result is a numeric matrix. And you can also do, let us delete this part, then it returns the whole second row and the whole third row, right? So you can subset the subset matrix in a very different ways. And that's it in this slide. And arrays. An array is very similar to matrix, but it can have more than 2 dimensions. It can be 3 dimensions, it can be 4 dimensions, 5 and 6 and so on. But I haven't used more than 3 dimensions, more than 5 dimensions using array command, using array data types. So here, actually, the array is created by creating a vector, just like a matrix, and you can specify the dimension using this dim input argument, the second argument. So it means that 5, 5, 2, it means that it generates an array of 5 by 5 by 2, meaning that you would have 2 5 by 5 matrices. So here it fills by column 1 to 5 and 21 to 25. This is the first matrix. So the what actually here leaves as a blank means that all rows and all columns at the first array and all rows and all columns at the second arrow. You understand that? And here another example. So it's a numeric vector from 1 to 100, and its dimension is 5 by 5 by 2 by 2. And by using this square bracket and leave these first 2 elements as blank and 2 by 2. So you can think of this command as you have a big 2 by 2 matrix, and at each section you have, what is that? 5 by 5 matrix. So these 5 by 5 elements, to subset this one, you can what you have to do, what you have to write is x square bracket, leave the all rows and all columns first and first. So here is the this bigger matrix is a indexes of this bigger matrices, bigger matrix. So here is 1, 1, 1, 1, 1, 2, 2, 1, 2, 2. So this one, the types of this result is matrix. So you can reopen a square bracket here, 2, 3. Then what is the result? The result is 87. This one. Well, I will show you why. Oops. X is an array, so it has 4 5 by 5 matrices, and comma 2 2. It returns the last matrices, and it's because this is matrix, and you can subset after bring a subset of array 2 and 3 is 87. Okay, and still you can use here C 1, 2, C 2, 2, column 5. Then it brings up the first and second row, and this whole thing from 81, 86, 91, 96, and 82, 87, 92, 97. Okay. Well, that's array. So it's a bigger dimensional matrix. So far we have covered vectors, matrices, and arrays. The next thing is data frame. A data frame is more general than a matrix in that different columns can have different modes, numeric, character, vector, and so on. So here's an example of data frame. So D is a numeric vector from having 1, 2, 3, and 4, and E is a character vector with the same length. It has red, white, red, and the first element is NA. Here NA is a special element of R, which in this case are not available, which is a kind of a missing value. And F is a logical vector. So all these D, E, and F, they are in different mode, numeric, character, and logical. And using this data.frame function, you can create a data frame. So where the each column has its own mode, and all these three elements can be in a different mode. So the result, and you can use also a names function to define the column names of that data frame. So here, using this concatenate function, C function, ID color past is a character vector, and using this names function, you can define these column names of this data frame. So my data, which is a data frame, has the first column is numeric vector, and second column is character vector, and third column is logical vector. That's the data frame, and it's the most, I think that it's the most general format, general type, and the most often used type in R, because we can have a different mode in one R object. So I will skip showing this example using R. The next slide, you can also subset this data frame. There are several ways to identify the elements of a data frame. So here, what is this one? This is a sequence function from 2 to 3 by 1 increment. And so from my data, I want to return the second and third column. Actually, precisely speaking, I want to extract the columns from second to third. So it returns these two columns from my data. The same. So the way of subsetting is is same to the way of subsetting from a matrix. And here you can also use the column names. So my data, a square bracket, and this is a character vector, and which indicates that here the C, ID, and color indicates the column names of my data. So it returns the first column having the ID, the name of ID, and the second column having the name of color. And you can also use this symbol here. I don't know if this can be said dollar symbol. Is that right? Anyways, you can use this symbol. So in front of the symbol, you can type the name of data frame, and you can after this symbol, you can type the column name of a column name that you want to specify, you want to identify. So it returns the third column of my data, this one, as the logical vector, and this is a row vector. And I say again, there is no distinction between row column and column. Row vector and column vector. And here's another example. So you can type the whole data in the data.frame function. The first argument is a character vector, which name is city. So city equals to C concatenate function, and you can type the data, which type is character. Here Seattle, Washington, Chicago, New York, Portland, St. Louis, and so on. So this is the first argument, and its name is city. So in this data frame, the name of first column is city, and the second column is a numeric vector, 196, 94, and so on, and its name is length. So here, from C to this parenthesis, this round bracket, this is the first column of this data.frame, and from R to this round bracket, this whole thing is the second argument of this data.frame. And by creating this data frame, we want to store the whole thing, which is R objects, into the name of a series. Then it generates this one. The name of first column is city. The name of second column is length, and it stores the data in there. Well, I will do this example using R so that we can go to the next contents. Delete these things, and I want to clear the whole workspace. Copy and select those things and run. Then we have our object series in data frame format. Okay. And list. Well, did I do something unuseful? So the last type of I'm sorry, this is not last. So the next type of data type is list. Is an ordered collection of objects. Like vectors, you can refer to elements in a list. The list is the list that we always imagine. So we can refer to elements in a list by position, actually using this nested square bracket. And a list allows you to get a variety of objects on the one name. So for example, here using list function, you specify 1, 2, 3, 4, 5. The first element of this list L is 1. The second element is 2. But what is the difference between list and the other objects? The difference between list and data frame. Actually, the elements in a list that can be any, those can be any type of R, any data type of R. Here we have an example. So A is just a single character value, design of experiments. Why this is design of experiments anyways? So I will do this example. So what you can do is, I will delete these symbols. So the A is a character which is defined between this double quote, and B is a character vector which length is 2, and C is a matrix which dimension is 7 by 10. And here, so A, we have different modes: A, character; B, numeric vector; C, a matrix, numeric matrix. But you can store this whole thing into one single R object, which is D, using list function A, B, and C. So the first element of D is a character value, design of experiments, and you can refer to the first element using this nested bracket. Is just a single character value, and the third element of the list D is a numeric matrix. So I want to give some variation here. So because the results of this R statement, this R comment, is a matrix, so you can subset this result using something like this. Here, the second row and third column, the 16, the numeric value is returned. So it's understandable, right? So the list is very convenient. You can just type anything here. EX list 1 matrix 1 to 10 2 by 5, and you can also here you can also give a list in the list, like welcome, and 1 to 10. Then EX has, what is that? 1, 2, 3 elements. The first one is a single numeric value, and the second element is a matrix, and third element is a list having 2 elements here: welcome, character value, and a numeric vector. So the way of referring this, the first, this first element of this list is you have to use the nested bracket twice. This is a third element, which is a list, and the first element. And the second element of the inside list is numeric vector, and I want to get from second element to sixth element, then it's 2, 3, 4, 5, 6. So the R evaluates the expression in the sequence in the order of left to right. So this one is a list, and this one is a vector, and this one is also a vector. The final result is also numeric vector. So list is a very convenient data type to handle various types of R offsets. And vectors, this is the last type. So sometimes a variable can be nominal by making it a vector. The vector stores the nominal values as a vector of integers in the range of 1 to k, where k is the number of unique values in the nominal variables. Here's an example. So, for example, this i.colors, which is an R object, is a character vector, which length is 1, 2, 3, 4, 5, 6, 7. Its length is 7. And character vector. So i.colors have these 7 values, but there are only 3 distinct values brown, blue, and green, right? Then using this factor function, you can convert this character vector into vector type. Then using this levels function, so now here this eyes dot colors is a character vector, and because we used factor function here, this I dot colors is a vector, and it has 3 values. So to know the unique values in a vector, you can use this levels function. Here's blue, brown, and green, and actually R recognize these 3 values as a 1, 1, 2, 3. This sentence means that the vector stores the nominal values as a vector of integers in the range from 1 to k. Okay, so even though this is blue, R recognize this blue as 1, and brown as 2, green as 3. So actually there is a function str. Actually this str is short for structure. So display the structure of an R object. So using this one, the input argument of str is an R object. So using this function, it shows that, okay, this I dot colors is a vector with 3 levels, blue, brown, and so on. And the values are 2, 1, 1, 3, 2, 2. 2, 1, 1, 3, 2, 2, 2. Just like that. So actually this is a very important data type to perform data mining. So to use data mining techniques, especially the classification techniques, all some specific columns, which is a dependent variables, which is the nominal type, should be defined as vector in R. That is vector, and you can convert the data types. Type conversions in R work as you would expect. So as the syntax of converting data types, syntax for the converting data types is s dot something. S dot character, S dot numeric, S dot matrix, S dot list, S dot data frame, S dot integer, S dot vector. So, for example, assume that you have a numeric vector from 1 to 10, which length is 10. So, if you type S dot character, open parenthesis, and write here C, not C, 1 colon 10 and close the parenthesis, then it generates, I will do that. So you can convert the type as character 1 to 10. It returns the character vector. It converts this 1 as a character value. Okay? And there is a way to check whether or not some R object is a what kind of type. So is that character, if the R object inside of this function is a character, then it's a character vector, then it returns true. If not, it returns false, which is a logical value. So like, is that numeric 2? It returns true. Is that numeric AAA? False. Okay. So there is a comments of is character, is numeric, is matrix, is list, and so on. So you can check if the type of an object is what you expect. So these are also useful commands to convert the data types in R. Here is an example. So D was a list, and the first element of D was a matrix. So is that matrix D of ID of D, the first element of list D? It returns true because it's a matrix. And we convert this first element into a data frame using s.data.frame command function. After that, we'll type the same command. Is the matrix? The first element of D is matrix? No, it's a data frame, so it returns false. Then is data frame? Yes, so it returns true. And R, well, it says again that R is a calculator. Just 1 second, please. Because R is a calculator, you can do a square root and addition, subtraction, multiplication, and division, and powers as well. And it also provides exponential function, log with sub 10, log with sub 2, and modulus after the division, and round, floor, ceiling, and choose k, which is a combination in a probability context. So, for example, choose 3, 2 is the number of combinations that you can select from 3. So it returns 1, 2, 1, 3, 2, 3, 3. And sign, the sign of R object. If it positive, it generates 1, it returns 1. If it negative, I don't know if that is a 0 or -1. Let me try. Sign -1. It's -1. Yeah, okay, so 1 or -1. So it provides that kind of built-in functions. Actually, you can do all those calculations using R, and well, this part is, I think, one of the most important part. So actually, you can do matrix and vector computations using R. So the default is element by element, element-wise computation. So here example, A is a 2 by 3 matrix, which elements is like that, which elements are like this, and B is a 2 by 3, also 2 by 3 matrix. So A and B has the same dimension. So if you multiply these two matrices, then it basically, actually by default, it basically computes element by element. So 1 times 7 is 7, 2 times 9 is 18, 3 times 11 is 33, just like this. So this A times B returns the same dimension, returns the matrix with the same dimension of A and B. And A divided by B actually is to the same element by element computation. So 1 divided by 7 is 1.1428 and so on, that blah blah blah, and 2 over 9 is 0.22222, and 3 over 11 is 0.27272727, something like that, and 4 over 8 is 0.5, 5 divided by 10 is also 0.5, something like that. So please keep in mind that basically the matrix and vector computation is element-wise computation. But what we have to do sometimes is real matrix multiplication or real dot product. So the A here, this means that we want to subset A that returns all rows of A and first and second columns of that. So the results is 2 by 2 matrix, and we also subset B, which results is 2 by 2 matrix. So here, if you want to do real matrix computation, this means that 1 times 9, 1 times 9 plus 2 times 10. So 9, 20, 29. to do this matrix computation, so in a matrix computation, as you know, matrix multiplication, as you know, the number of rows of the first matrix and the number of columns of the second matrix, they should be the same. So to the matrix multiplication, you can just type this percent symbol before this star, before and after this star symbol. So these R commands does real matrix multiplication. And unfortunately, there is no specific function for dot product of two vectors. So here, A is a numeric vector which length is 5, and B is also a numeric vector which is length is 5. Actually, they are the same. A is 1, 3, 5, 7, 9, and to define B, we just use sequence function from 1 to 9 by increasing 2. So it's 1, 3, 5, 7, 9. So because basically it computes element-wise multiplication, A times B generates 1 times 1, 1, 3 times 3, 9, 5 times 5, 25, something like that, 7 times 7, 49. So to the vector dot product, to do this computation, we just do this element-wise multiplication. After that, we just add those all values using sum function. So it sums up all these elements in a numeric vector. Is it understandable? It's pretty simple. So to the dot product of two vectors, you have to use this sum function and this star symbol to do element-wise multiplication. And as I just showed you before, this sum function sums up all elements in a numeric vector. So if you add from 1 to 10, then it's 55. I'm sorry. And there is another function which is a cum sum. It's a cumulative summation. So 1 is 1, and 1 plus 2 is 3. 1 plus 2 plus 3 is 6. 1 plus 2 plus 3 plus 4 is 10, and so on. It's a cumulative sum. And if you use a matrix as an input argument of this sum function, that if the mode of this matrix is numeric, then it sums up all the elements in a matrix. And here is another function which is call sums. Means that it sums the elements by columns. So 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9. And row sums it sums the elements by rows. So 1 plus 2 plus 3 is 6. So it returns a numeric vector. And here is R computes the average of a numeric vector and a numeric matrix. So here the average of from 1 to 10 is 5.5, and the average of 1, 2, 3, 4, 5, 6 is 3.5. And core means it computes the averages of each columns, right? So the average of 1 and 4 is 2.5. The average of 3 and 6 is 4.5. And row means it computes the averages of each rows. Next. And there is a very useful function which is apply. Is to apply a function, is to apply another function to parts of a matrix or array. Well, actually I often use this one with a matrix. Use this apply function. So this syntax is apply, and the first argument is a matrix, and the second argument is whether the second argument decides whether or not apply this third argument, which is a R function, row-wise or column-wise. The value of second argument could be either 1 or 2. and function is the function that you want to apply. So let us look at this example. A is a 2 by 3 matrix, and its elements are like that, and apply to A row-wise this mean function. So row-wise compute the averages. The average of 1, 2, and 3 is 2. The average of 4, 5, 6 is 5. So it applies, again, A row-wise this mean function. Is it understandable? And here, the difference between this one and this R command and this one is just it computes the average column-wise. And cum sum, row-wise, 1 plus 2 is 3. 1 plus 2 plus 3 is 6. Right? Okay, so now you can understand how to use this apply function. Well, if you get more familiar with this R software, then you would know later you will know this function is very useful. And it also computes standard deviation and variance using SD function and VAR function, SQRT function, which is the squared root. So, well, actually A is a numeric vector from 1 to 10, and its variance is this one, 9.16. And you know that the squared root value of variance is a standard deviation, so it generates the same value, 3 point something here. And, well, the matrix, well, if you, actually you can use this SD function and various function with a matrix. And for the matrix, the variance function actually computes the covariance matrix of a matrix. Is it understandable? Okay. And, well, okay. This is an example of using apply and SD function at the same time. So A is 5 by 2 matrix, and we want to apply this SD function to A. What is this? Row-wise. So the standard deviation of 1 and 6, the standard deviation, and 2 and 7, they are all 3.53. And this is column-wise. So the standard deviation of 1 to 5 is this one, and the standard deviation of 6 to 10 is this one. So you can use apply function and SD function here. And it also finds the minimum value and the maximum value and the location of minimum value and the location of maximum value using those 4 functions: min, max, which dot min, which dot max. So A is a numeric vector. What is the minimum value? It's 1. It returns 1. What is the maximum value? It's 10. It returns 10. And then what is the location of the minimum value? To do that, we start min A. The minimum value is 1 and is a third element of A. So it returns 3. And the location of maximum value is 5. So it returns 5. And you can also use those functions with apply function. And, well, and that's it. And, well, yeah, here you have a matrix. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can extract out some specific value that you want using this square bracket expression. Then actually you can change the value of this location. So I want to change the value of this second row and second column, which was 7 to -2. Then it replace this 7 with -2. That's just way. And here is another example. I want to delete this 4 and I want to insert 100 in there. You can do, you can also use this kind of R expression. And other functions for matrix is T. It's a transpose. It's just transpose of a matrix. So the result is the transpose of 2 by 3 matrix is 3 by 2 matrix. And DET is to calculate the determinant, and solve function is to compute an inverse matrix of a square matrix. And diag, D-I-A-G, is to return the diagonal elements of a square matrix. So if you use sum and diag function at the same time, like that, actually the matrix B is 4, 7, 2, 6, is to calculate a trace of a matrix. What is the trace of a matrix? Trace of a matrix is the sum of diagonal elements. So you should use these two functions at the same time. So this function, diag B, returns the diagonal elements of B, which is 4 and 6, and the sum of these two elements. So it calculates the trace of this B matrix. That's all about matrix and vector computations. And what is also good about R is you can read and write the data from and to R. So the first one is you can write the data in R to external files. You can save the data into external files using this write.csv. Actually, we know that there are another types of another formats of data files such as .txt, .dat, .xlx, .csv. But in the R society, the statisticians often use this CSV format. So I will just introduce this write.csv and read.csv functions. So previously, actually, we had this R object. We created this series object, which is a data frame, because the first column is character vector and the second column is numeric vector. And I want to save this data to external CSV file. Then we can use this write.csv function. The first argument is R object, and the second object is a character value, which indicates the name of file that you want to save. And row names false means that you can just we do not save the names of rows, and call.names is true. Then the first row of the saved file stores the names of data frame here, actually. So I want to do this one using R. Well, do we have series? Oh, yes, we have. We have this one. And actually, I should mention this. I said that the second argument, write.csv, is a file name. Actually, you can type in there the absolute address with the file names, but often we just type the file names only. So I recommend you to first define your workstation, set working directory. So by doing this step, just go to session and set working directories and choose directory. Then you can choose, well, for example, my computers, C drive, users, what is this? Desktop. Okay, my working directory is desktop, and I want to choose this one. Then you can interact with the files with that folder. So I will do, let me try write.csv. write.csv function, and the first argument is a series, which is R object, and the name of files test.csv, and call.names equals to true. I don't know why this one returns that. Then on the desktop we have this CSV file, and the first row has okay, because I didn't set up the row names. It stores the row names at the first column, and it also stores the row names on the first row, and these are the data set. Okay, so we have test.csv on the desktop, and I would delete this series using rm function, which stands for remove. Then series has gone. I don't have a series, but I want to make a series again using read.csv function, and the first argument is the name of file, and the second argument is whether or not the first node is header, which means that the column names, and the third argument is what the data elements are separated by what. And because the CSV file distinguishes the element using comma symbol. Okay, on the desktop, in my working directory, working folder, I have test.csv, and the header is true. I want to use the first row as a column name, and the separation is comma. I'll be back. I'm sorry, the security staff was checking this classroom, so I just have to stop recording. Well, I'm back. So now by using this function, read.csv, now we have series. But it generates another column because we have the first column here, the data. Okay, so if you do not want to this first column, then you may have to delete using, using this one. Anyways, I will leave this thing to you, so you try by your own to import the data, the part of data that you want to import. Anyways, we can use this read.csv and write.csv to, save the data into file and to import data from file. And that was the function. Well, and the others, the next 3 slides are about data manipulation, selecting subset of data. Actually, if you install this R, then it has several packages installed as a default. But that does not show that. Let me US REST. What is that? US or REST. So actually this US REST is a built-in data that R provides by default. So it's a data frame. You can see that. Is it data frame? Let me check using is data dot frame. USA RRS. True, it's a data frame, and it contains the information about the number of murders, assaults, and urban population and rapes for all states in the United States. Now, in America, from Alabama to Wyoming. Well, and you can select subsets of data using this one. So what does this mean? Because US arrest is a data frame, this command means that I want to select 10th, 20th, 30th, it's hard to pronunciate, rows and all columns. So it selects Georgia, Maryland, and New Jersey, and all 4 columns were selected. And you can use this conditional expression, and you can see that here is a square bracket, and the first element in the square bracket, it indicates rows. Then what is this one? US arrest is a data frame, and using this symbol, urban pop is a column name. So this one is what is the type of this one? The type of this one is a numeric vector. And here is a comparison operator, which is greater than or equal to 70. So this one is, it compares this numeric vector with this single number element-wise. So the third column is, what is that? The urban population. It compares 58 with 70. Is that greater than 70? No. So it returns false. What about the second element? Still false. And the third element is 80 is greater than 70, so it returns true. Sorry. And so on. So from U to this 0, actually the first element, this square bracket, what is the type of this one? This one is a logical vector. Right? Then it returns the rows corresponding to the two true values. So because here the second element of square bracket leaves as blank, it returns all 4 columns with the rows that satisfy this condition. So the Arizona state, this one satisfies that, the first one, right? And the California is 91, which is greater than 70, so it returns this one. So all these rows actually are corresponding to the true values of this logical vector. Okay, so to subset a data, you can still use this square bracket convention with a comparison expression. And still, you can use here, what is this one? Here, you have 2 conditional expressions. The first one is here, and you have and symbol here, and the second conditional expression. So I want to subset, I want to get the rows that satisfy these 2 conditions at the same time. So I want to get rows that reach urban pop is greater than or equal to 70 and is rape is greater than or equal to 40. So because this data frame, this subset satisfies the first, the first condition, we can just see whether or not this rape column satisfy this one. What is the rows that satisfy this column? This condition is California and no. Where's Nevada? We should have Nevada, but I don't know why this doesn't have Nevada. Anyways, these two rows satisfy these two conditions, and it actually from U here to 0 of 40, actually the type of this R expression after evaluating this R expression is also logical vector. Okay? And you can also add or remove columns. Here, well, we have a subset using this one. Okay, I want to have a subset that satisfies its model is greater than or equal to 15. Then these 4 rows has been selected. And I want to add the first column here. And I want to name it as ID because there is no column of ID. It creates another column, which column name is ID here. And it inserts the value in there. So the length of this one, the length of first column should be the same with the number of rows of this data frame. Okay? Well, and you can also delete columns using this negative minus symbol. So now we have 1, 2, 3, 4, 5 columns in these R objects, US Oresta sub 3. And I want to remove the second column, which is assert. Then I want to have all rows without having the second column. Then this minus 2 expresses that I don't want to have the second column. And I want to save it into US Oresta sub 3. Then it returns this 4x4 data frame, and it doesn't have this column. Okay, so you can remove the columns and combine rows and columns. So for example, you assume that you have 2 data frames where their number of rows are the same. Then you can combine these two using C-bind. So for example, you have 2 data frames and the number of rows are the N1, N2, N1 equals to N2. Then you want to have a single data frame that is generated by adding those 2 things into here. Then you use, if you want to do that, you use this C-bind function, and you have 2 data frame with columns C1, number of columns are the same, and you want to have a long data frame. Then you use R-bind, which means row bind and column bind, column-wise bind and row-wise bind. I hope you to try this example by yourself. And R also provides some probability and random values facilities. Here are several examples, but I hope you to hope you to use the help function to to get more information about probability functions. So here, R unif, it generates a random number from uniform distribution. So this function and this input argument is the number of random values that you want to generate. So this command generates a continuous uniform random values between 0 and 1. So using you generate a single value from uniform distribution, which minimum value is 1, which maximum value is which minimum value is 0, which maximum value is 1. And here R unif with input argument n, for example 5, then you generate a uniform random numbers, 5 uniform random numbers. And for what is this one? Generate a random integer between 1 and k, because this one, R unif 1 generates a random number from 0 and 1. You multiply k, then the space from which we can generate random number is extended from 1 to k, right? And we just floor that, then any number generated from here is 1 to k. Where is that? Just a second. Right. So the range of random numbers that we can generate is 1. It becomes, because we use floor function, it's between 1, not 1, I'm sorry. It's between 0 to k minus 1. And by adding 1, we can generate a random integer between 1 and k using this function. Okay? And sample, it generates a random permutation of integers. So, for example, sample with 10, it generates a randomly shuffled sequence of a numeric vector 1 to 10, right? And this is very useful to shuffle rows and columns, so I want to show that. So, for example, sample 5, 2, 5, 4, 3, 1, 5, 4, 2, like that. It's just randomly permutate, shuffle the numbers, okay? And sample nk generates a random selection of k unique integers between 1 and n. So this is a sampling without replacement. So sample 10, 6 is we want to randomly select 6 numbers from 1 to 10. Okay, like this. So the first argument is the maximum value of integer, and the second argument is the number of random values that we want to generate. So it's like in a pocket, there's numbers from 1 to 10, 7, 8, 9, 10, and we select 6 numbers by blind sampling. Okay? And our norm is to generate a random number from normal distribution with mu and sigma. So the mu is here, which is mean of this normal distribution, and the sigma, the third argument indicates the standard deviation of the specific normal distribution. So it generates a random number from a normal distribution with a mean of 5 and standard deviation of 1. The norm computes the probability density function value at x for a random variable from normal distribution with mu and sigma. So, for example, here the norm 3, 5, 1 means that we have a probability distribution, which means is 5, and which is standard deviation is 1. And we compute what is the probability density function value at 3. It computes this one. This is a 0.0539 dot dot dot. And the p-norm computes the cumulative distribution function values at x. So the difference between d-norm and p-norm is d-norm computes the probability density function value at a specific x value, and p-norm computes, so here the example is 6 here, computes this area, the cumulative probability value. And we also have a set seed facility here, set the random number generator back to the known state. So here is an example. Set the seed 1. The argument is to memorize multiple stations, multiple states. So here 1 indicates I will specify this time as 1, my current time as 1, and all UNIF generates a uniform random number. And if you run the same code again, then it generates another number. But I want to generate this one again, meaning that I want to go back to the time that I generated this, the time where when I generated this random number. Then use this one using the same argument, because I save my previous time as 1. Then set does it 1 means that I go back to the time that I generated this random number. And after that, if you run this function again, you can get the same random number. So it's the set.seed function is to save the time position that I want to go back later. Okay? And as I said before, you can define your own function, your own functions using this function command. And its syntax is you can specify the name of function, and you can specify multiple or single arguments that will be used within the function statement. So the syntax is, the structure of function is like that. The name of function, left arrow to save all these contents into this name, and use this function, and open the round parenthesis, round bracket, and specify input arguments and close round bracket, and open this one. And you write your own code here and specify what should be returned as a output of your own function, and then close that. That is the syntax of defining function. So this one shows a very simple example. So this function f has two input arguments, x and y, and I want to add these two, and I want to return the value of adding these two x and y, and I defined this function as f, and now I can use this f. And second argument is 2, and the first argument is 2, and second argument is 3, and it returns 5. And this one, so if you can define your statement as a single line, then you don't have to use these brackets here. But if you need to specify, and we often do that, if you need to specify multiple lines of our comments, then you have to use these two. So this function does the same thing. And I defined here a function having 3 arguments, x, mu, sigma. So you can specify your own things here. And y is defined by computing this one, exp. So this is actually pretty much what is this one? Root 2 pi sigma over 1 times exponential, what is that? 2 sigma square over minus x minus mu square. So actually this y basically computes the probability density function value of normal distribution with mean of mu and standard deviation of sigma. So it should function same as d norm function here. So I defined this function that returns the value of y, which is the probability density function value of normal distribution, and I stored these contents into my d norm. So here I want to compute the probability density function value at 0. So here is a normal distribution, which means it's 5, which average is 5, and the standard deviation is 4. And what is the normal distribution function value at 0? Is 0.0456. And d norm, which is a built-in function, generates the same value. So you can define your own function using this function. It's interesting. Okay. And you can also use the if statement to, just like any other general purpose programming language, and its syntax is if. In the parentheses, you can specify the condition. And if that is true, so these statements are evaluated only when this condition is true. So if that is false, evaluate these three statements. So here is an example. X is 5. If x is less than 3, print x is less than 3. Else, print x is not less than 3. Because 5 is not less than 3, this condition returns false. So this expression is not evaluated, and but this expression is evaluated. So x is not less than 3. Now try with x of 0. Because x0 is less than 3, it evaluates this one rather than this one. So x is less than 3. So you can use if statement. So to use this if statement, we should be able to work with this comparison operators. Equals to is depicted by these two symbols. Not equals to is this, and less than or equal to, and less than, and greater than or equal to, greater than. And you can use these Boolean operators and not or. So here, the examples of operators, comparison operators and Boolean operators. X is 3, and pi is, actually this is also a special value that R provides, which is pi. This one. 3.14, 1593. Is x equals to pi? No, so it returns false. Is x is not equals to pi? Yes, it returns true. X less than pi? True. X is less than or equal to pi? True. X is greater than pi? No, it returns false. Just like that, we can use these comparison operators. And these comparison operators, as I said just earlier in this class, the vectors can be compared using these comparison operators, and it compares element by element. So x has 3 pi 4, y has pi pi pi. X equals to y, because the first elements, no, false. The second elements, pi equals to pi, yes, so it returns true. 4 equals to pi, no, it returns false. Something like that. All the examples are the same thing. And here is a very useful function that are any and all. And the input arguments of these two functions is in logical vector. X equals to pi. X is actually a vector and pi is a number, so it compares with 3 and pi, pi and pi, and 4 and pi. And because, so it actually this one is a logical vector, which is false, true, false. So if there is any true in there in logical vector, it returns true. And or is if there is any false, it returns false. So to return the true value from all functions, from this all function, then the elements in the logical vector, which is an input argument to this all function, the all elements in there should be all truths to return the true. Okay, so these two functions also very useful. And for loop statement, and there's a while loop statement as well, and it's the same. So the syntax is like this: for there's a sequence which is a numeric vector and the statement. So during this sequence, we do these R statements. Let us see this in simple example. X is a numeric vector from 1 to 10. Actually, you can type like this, the same result. And Y is 0. And for I in this one, the length function actually returns the length of vector. So because the length of X is 10, actually it's same as 1 to 10. So from 1 to 10, for I in this sequence, we add, actually the initially Y was 0. 0 plus X's first, X's first element is 1. So now Y is 1. And I becomes 2. So 1 plus 2, 3. Right? And now I becomes 3 and Y is 3. 3 plus, what is that? The third element of X is 3, 6. So you can do this one until I becomes 10. So actually this four statement computes addition from 1 to 10, which is 55. So it's just same as sum 1 to 10. Okay, there's a for statement. And a loop for which you do not know in advance how many times iterations there will be. We use loop while statement. So during this condition is true, we repeat these statements, this statement. Okay? So actually this is the same. It's to sum up from 1 to 10. So Y is defined as 0, I is defined as 1. And while this condition is true, I is less than length of X. Length of X is 10. So while I is less than or equal to 10, we repeat this expression. So now Y is 0 and 0. 0 plus I is 1. X is first element is 1. It goes to Y, which is 1. So Y is 1. And I want to add 1 to I, then I becomes 2. So it repeats this procedure, then we finally get Y, which is 55. And because this statement is also evaluated, this I left arrow I plus 1 is evaluated at the last, I becomes 11. Hope you type this example by yourself using R and check how this statement, this loop, while loop statement works. And I said that we can download and install our packages from that CRAN website. And one of the strengths of R is that the system can easily be extended by adding the R packages that you need to install. The system allows you to write new functions and package those functions in a so-called R package or R library. The R package may also contain other R objects, for example, datasets or documentation. So into R package, it can include datasets, functions, and documentations. When you download R, already a number of packages are downloaded as well and installed. Well, actually, let us go back to RStudio. In the package tab, you can see several packages here: boot, class, cluster, code tools, compiler, and so on. Those packages are installed by default when you install R. So you can use those functions by default, but it's not on the current session. To attach, for example, this class package to the current R session, you can just simply click this button. Okay? Then now you can use this class, the functions and datasets in this class package. So here, if you uncheck this one, then actually it's the same with writing and learning this detach function. So you can use library, you can type library class. Then you can see here is checked, and detach class. Oops. Oh, it's a typo. What is that? Detach class. Do I have to write this one? Unload equals to true. I don't know. Let us just click this one. Anyways, you can, but it's worth mentioning that you may have to remember using this library function to attach a package to a current session, to your current R session. And to use a function in an R package, that package has to be attached to the system using that library function, or click the square button. And when you start R, not all of the downloaded packages are attached, only 7 packages are attached to the system by default. Okay, so using this search function, you can see what kind of packages are attached to the current R session. And those packages are attached, and the functions and data tables, data sets, data frames, and the documentations stored in those packages. You can use all of those. And to add an additional package, actually you have 2 ways to do that. The first one is you can simply click this install button, and if you know the name of the specific package that you want to install, I know that E1071, there's a package called this one. Then type the name of package and install to library, just set to default and install. Click. Actually, the install dependencies, it means that some packages need another packages to use that, to wholly use all the functionalities in some specific packages. Actually, it should invoke several additional packages. Then actually you'd better leave this as checked. So click install, Then if your computer is connected to the internet, it goes to the CRAN website and search for that specific, this E1071 package and install to your computer. Then now we can see here E1071 package is installed in this computer. But because here this one is unchecked and I have not used library function to use the functionalities of E1071 packages, I cannot use anything in there. But by clicking this one or typing library E1071, now I can use all the functions in there. Okay? For example, well, what kind of things this one have? For example, it can cluster. Actually, this package has many functions of data mining techniques, like naive Bayes and plot, I say. So for example, now I can use best.svm. Then, well, I want to know what the best.svm means. Best.svm. Help me, please. Then, because that E1071 package contains this document, it shows the details about the best SVM. And what the I don't know what the input arguments and how to use it. It shows the detailed information about this best.svm function. So you can use additional functions from installing and adding packages from CRAN website. And what you should know is that actually, well, many professional statisticians, they developed many functions of doing data mining or statistics. There are many things out there, so you can just use it. You don't have to program. For example, we will learn about logistic regression. You don't have to program the algorithm of logistic regression by yourself because someone already implemented it. So you can just download the package, having the logistic regression facility, and install it and use that function. So that's the very big power and very big convenience of using R. So that's why I recommend you to use R for data mining class. Actually, it's not just to do your homework and term project. After this class, after this whole semester, you can use this R software by your own another specific purposes. So that's why I spend this time to introduce you R software. Well, and there's a package facilities, and okay, so here is to attach a new package to your system, your current R session, you should use this library command. And all packages are available in CRAN website. Okay, I didn't tell you the second way of installing on our package. So let us go back to this R website. Then here is the packages, link of packages. Click this one, and table of available packages sorted by name, or sorted by, what was that? Sorted by date of the publication. So from recent thing to the old thing. Well, I usually this option, stored by name. Then there is a lots of packages in there. So, for example, multivariate, I don't know about this. Well, multivariate Bernoulli log linear model. So all the functions to do this, to build Bernoulli log linear model, you can just download this package and install to your computer. So click this one, and there is a document manual to use this one, and there is a source code, not a source code, I don't know, but there's a zip file. There must be a zip file. This one are Windows binaries. This one, click this one. You can download this zip file. I will save it to the desktop. Okay, the size is usually that is not that big. Then I have a compressed file in a GIP format, and you can just save this file, this zip file, to the location of R, program files. Well, where is it? R 3.1.1, and library. There's packages, folders corresponding to the packages, and I just installed E1071 here, and all the functions are here. So you just copy your G file here, okay, and extract out the files. Okay, then it generates MVB, what is that? 1.1 folder here. Oh no, this one should be in this hierarchy. But this is an inconvenient way to install our packages, so I do not recommend you to this one, to do this one, but you may have to do this one when you are not connected to the internet. Then that's the way to install new packages, but you should have that compressed file in a zip format. Then I added this folder to here. Okay, let us go back to RStudio, then packages. It should have refresh. Here, MVB 1.1, right? It is added. Okay. And that is about packages. And graphics. You can draw histogram and dot plot and box plots and scatter matrix, scatter plot matrices, and there is a LaTeX package that provides all useful facilities for drawing very nice graphs, such as density plot by groups, and dot plot by groups, and dot plot by two groups, and line plot, and box plot as well. And well, I may have to finish this class, so I will just show you several examples. So here, some easy examples. So actually, Iris is a built-in data frame. This data set provides by default. Well, is there any other slide to explain Iris data? No. Okay, actually this is a for loop statement. The sequence is 1 to 4, and so it means that we repeat these two statements 4 times. So we want to draw histogram of first column, second column, third column, and fourth column of iris data. Well, I may have to do. I will erase everything. The call names function actually extracts the column names of data frame. So iris is provided by default, and what does this look like is it has 1, 2, 3, 4, 5 columns, and first 4 columns are numeric vectors, and the last column is character vector. So this is a data frame, and it has 150 rows. And this command, call names, extracted out the column names of this data frame, which was here. Sepal.length, sepal.width, petal.length, and this one, and species. So what is the type of CNAMEs? It's character vector, which length is 5. And what does do is now I from 1 to 4, it creates a histogram of, what is this one? This one is the first column, because I is now 1, the first column of iris, this is a numeric vector, and breaks means that the number of beans in the histogram, and color is to specify color. So now I is 1, the value of color is 2. Actually, the various colors match to the numbers in R. So I hope you to find what colors are corresponding to what numbers, which numbers, by yourself. And the main is the title of, so it first blank remains as blank, and specify the title of a histogram again by using those character values. So if you do this one, it generates 4 histograms. Okay? And the title, actually, this title comes from this third element of CNAMEs. This one comes from this one. Okay? This is one example to draw histogram, to draw some graphics, to get some graphics from R. And this one is this example is to draw a scatter plot. You can use just simply plot function. And the first argument is the coordinates of x-axis, the horizontal axis, and the second argument is the coordinates of vertical axis, the y-axis. So the length of this one and the length of this one should be the same. Okay? And you can draw box plots using box plot command. And well, now I think you can understand what these R commands means. So I hope you check what each line means by yourself. And please learn, type these commands in R by yourself, by your own, and understand what those commands mean. And scatter plot matrices can be drawn by pairs function and density plot function, and there are many other graphics provided by R. And this is the last slide of this lecture note. So there are several useful links that you can get more information about R, and these 3 examples. And I recommend you to this is a kind of recommended reading materials, R cookbook or R in a nutshell. And these 2 books are the most often used textbook for R software. And These two books are written in English, and this one, 예제로 배우는 R programming. This book is written in Korean. So for the Korean students, I recommend you to read this book. And this book is the only one that is written in the perspective of programming. And the other books there are lots of R books, even in this country, in Korea, but they are all about how to use R functions for statistical analysis, not for programming. So this book is only one that is written in the perspective of programming. So I recommend you, if you want to know more about R software, then you can use this one. So that's it. That's all about all that I prepared to introduce you R software. And I hope you is now the duration of this record is approaching 2 hours and 20 minutes. So after watching this video, I strongly recommend you to do all these examples in lecture slide by yourself. So install R Studio, and try all these commands by yourself to understand what each of those means. Okay? And in the next class, I will upload a useful material for R command that summarizes some useful R commands. So please practice that one. So because this is kind of programming language, this is actually a program language. There is no shortcut to be professional, to be familiar with our software. Just many practices. That's the best way to play with R with pleasure. Yeah, so I hope this class be helpful to you, and in the next class we will begin with the first classification technique, which is logistic regression. Okay, thank you.